Hello, this is Dan. I just wanted to introduce you to my project, Video Object Removal, and a little bit of how to set it up. Can be quite complicated, but here we go. Basically, I'm logged into my school server through an SSH connection, and what I'm operating right now is basically in the Linux, on the Linux server in the school. And what I've already done is install Docker, the latest version of Docker with the NVIDIA on top of that, the NVIDIA Docker version. You can go through basically how to set that up. It's quite good details in the documentation already. Also check the repository. And what I've done here is basically show, this is just a test of running it through a container that shows that yes, NVIDIA Docker is working in this correctly in this sense. So the next part is to set up the GitHub repository for project. So here I just clone my GitHub project. As you see here, I cloned this into a project folder called examples. What it's going to do is create a new folder called Video Object Removal, which is the actual project itself. Now changing to this directory, you can see where to go. The first thing to do is basically you want to get into the container, start setting up. Not in the setup, but basically go into detect. This is where the first one is perhaps detect. This is where the first container definition is given, and into the Docker folder. Now in the Docker folder you see a bunch of files. The one to run first here is the first file called create detector container.shell. This will step through a process, start pulling all the basically base containers needed for the project from the Docker hub and starts installing them. And what it's pulling here is images. I want to make more specific that these are basically pulling images off Docker hub. And this is what's being installed. What we're building itself is the image for the detect container. The difference between image and container can get a little bit into it later, but basically the image is the base definition. The container is the actual runtime instance of that image or an image. It can be different for each one. But what it's doing is basically it's taking all the information now, and what it starts building is the specifics which are defined in the Docker run file. This is all done internally. You don't have to worry about it. And it's going to build for a while. I'll let it go, and I'll be back in a few minutes when it's done. Now we're starting with the inpaint containers. You see here I've already changed to the inpaint Docker folder. You have a similar sort of setup. What you want to run is the build inpaint.shell script. This will start pulling the images from Docker Hub and also building the specifics as required for the inpaint container itself. Now we're here at the end of the inpaint container build. As you see, there's a few red marks, which usually mean something went wrong, but don't worry, we'll fix that in the next step. These are just saying that something couldn't be removed. What you need to do now is set up the network. Now this is defined in the base definition setup folder. Change to this video object removal setup folder, and then run the file called setupnetwork.shell. This will create the network as required for the detect and inpaint containers to communicate via SSH. In the next step, we're going to step through the setting up of each of the runtime containers themselves. So what we need to do is basically change them to the detect Docker container first and run the script called run-detector.sh. This creates the first running instance of the container itself. You can check this, that it's running and working, by using the NVIDIA SMI command. This shows the connectivity to the GPU, which is essential for this project to run. Exit out of here with a normal exit statement. The container at this point has stopped running, just a note. And you can see that we have these images built. Of course, I wanted to clarify this. What we did in the previous steps is we built the inpainting and the detector images, and however the images are not the containers. And so what we also show is that container ls shows that we have an empty list, which means there's no containers running right now. And we can basically go in and start the same thing with the inpaint container. So change to the inpaint and then change to the Docker folder. Also run the script called run-inpainting.shell. This also creates the first instance here of the inpainting container. Important here is we also need to run the setup script in the inpaint container. This is with the install scripts.sh. This builds or basically compiles the NVIDIA CUDA definitions required for PyTorch. Once that's done, it's happy. You can exit out of this container as well. Now if we do a container ls again, it's going to show that we essentially have no running containers at this point. Okay, images, yes. But what we don't really need is we need to see what the containers are running. And if you use a -all, this shows you also containers which have been stopped. So now that we have these first definitions, what we actually need to do is start them as a continuous running instance. And the way to do that is, okay, yes, I showed the same thing twice. But let's see, now the next part, we need to actually start the containers as a permanent running instance. This you'd use it with the Docker start command and then the container name. First detect, it basically tells you it's running, nothing else. Start in paint, same thing. And then you can again run basically a bash shell into that and see that it's running as well. And as you can see here, well, first what we have to do, if we go another bash shell into the detect container, you can see that these are the services, or basically the services which are running, which is very minimal, nothing really. What we need to do is set up the SSH. The way to do that is change into the base folder of the container and go into setup, and go into the SSH folder. What you have to do is copy the SSHD config file into the folder, the system folder called etc SSH. This will redefine how the connectivity for SSH will work. You have to use sudo for this case because it is basically a root folder and need to have permission to do that, so you can basically run it. Now that you've defined this configuration, it's okay to start the SSH daemon in this case. And the way you do that is quite simple. You just run within our sudo command, sudo service ssh start. This will give you a nice report that said it started the daemon as sshd. And then you can actually see it running if you use another ps-eaf command, and you can see it's running as user sbin sshd. Now exit out of the container itself. You can do the same thing by going into the inpaint container now, which is required as well. Go into the inpaint container bash within our bash command. What you can also do is what it arrives at is you're not in the home folder, you have to change one back, which I'll do in the next step. As you can see here, we ended up in the deep flow container itself, not the home directory. So again, change to the setup container and change to SSH. And once inside SSH, copy the SSHD config into the etc SSH folder again. Yes, I forgot the sudo command. We'll go back and do that because it is a project folder, or a root folder. Change this in here. Okay, now copy that itself. Now we're okay. We can basically start the SSH daemon or change the home directory, either case. So again, the same thing, sudo service ssh start. And check that it's running. You can see the SSH daemon running as well. And you can exit out of the container in this case. So now we want to check the connectivity to the containers through SSH externally. So what we do is you can run SSH directly. This is from the server itself, not within any container, but what you want to do is just run SSH. You have to use a different port definition, which is a port defined for each container. And here the first port definition for the detect container is 48171, and then you run it as the username app user at localhost. And it's going to ask you, do you trust, of course, enter your base IDS RSA. This is because I use also public key encryption, and you enter the password app user for the container itself. And as you can see, yes, we are in the detect container. Here we have the Detectron2 repo. You can exit out. Next, go into and do the same thing with the inpaint container, except its port number is 48172. Same thing, same question. into your passphrase for your ID RSA, and also app user for the password to the container itself. And you can see, yes, we are into the container. And it is here, and this is the deep flow container, since you can see the deep flow repository shown as well. The next part, I'll show how to download the models as required for the inpaint container. Can be done quite easily using the setup script. I want to show here when you try to start it and you say download inpaint models.script, which is in the setup folder, it's going to start complaining right now. It says permission denied, permission denied. And I'm not doing this, I want to show you basically failures as well. It's part of the project, what you need to figure out as part of the whole task. But basically what's happening, if you go back, change the inpaint directory, and what it's trying to do is copy files into a folder called pre-trained models. If you look at the permissions, these are actually the folders owned by root. However, we need to be defined under username, so you can use it using a chown statement. Use sudo chown user, basically, which changes it to the username of myself, which is camd1. And as you can see now, the folder is owned by myself. Now you can basically go back and run the same setup script, and it will run correctly, copy into the right folder. Now run this, of course. You can do this, of course, yourself by copying from the original author's G drive folder. However, I basically scripted all this. It's easier. It'll just do it for you. What it's doing right now is copying off G drive, putting them into that the inpaint pre-trained models folder, which we'll show in a second. Okay, now back in the folder, you can check to make sure that everything was okay, change to inpaint, and then change to pre-trained models. And what you can see now is we have all the models necessary to run the project. So yeah, we're back. Now I wanted to show actually running the process itself. And so what I have here is two terminal windows open, both into the same server. And what I want to start to do right away is basically start with a multiplexer screen session. And this is, I'll explain later, is a little bit necessary because we're running in a development environment. But what we can do, basically now we're in the screen session I here named app. But what we can see is we have our containers up and running, both the inpaint and the detect containers. And what I want to do is just open up a detect or a bash shell into that at this point. And then once I'm in the detect container bash shell, then I basically change to app and simply run the dash application using python app.py. When this runs, it'll start up. What you can see is it'll tell you right away that this is a development server and you shouldn't use it for production, but this is essentially why we're running this in a screen terminal multiplexer, which we can basically shut this off and put it in the background and it will still run as if it was active. And here I basically exited out of screen by pushing Control AD, and this basically brings you back to the normal terminal. We'll show you how to switch back to that later, but basically this is needed. You can basically run everything through a single terminal window. You can have multiple screens. It's quite nice in that way. It also, helps in case you have bad connectivity problems and you basically get locked out or, you time out from your connection. So what we need to do is know what our IP address is. You can get this easily with curl config.io. And this is my IP address. I'm not really worried that you guys will steal this because basically the server will be shut down in a few days. Now if you put this into the web browser and go to the port 8080, this will bring up the front of your Dash app. And basically this is what we see here. And you can get back into the normal, into the running screen by just say screen ls, and you can see it here. It was called app. Screen-r app connects back or reattaches this screen. And then now here we are in the app. And what I have is basically the layout is quite simple. There's three sections mainly. There's the first prediction, which is allowed the user to select and determine which mask to use. The next part is a sequence that shows how the masking has proceeded. And then the last part, which is inpaint, shows the inpainting results as they come out. And so getting back into where to start. So first of all, you want to load a file in. If you click on that box, then it brings up a little dialog box where you can pick your file which you like, or you can drag it into this region as well. It doesn't matter. And then once you do that, it basically brings back something which is your video, and it tells you here I've uploaded tram video MP4. And if you just run single or push the run single button, it gives you the first prediction on that frame, and it always starts with the frame at the first, or the starting frame number, in this case 0. And what you can see is that there's predictions for several things in here, but what I want is really only things which are related to people, so a person, handbag, a backpack, and a suitcase. If I rerun the run single, then it predicts only on those type of items. I can see the same thing if I move down to a very later sequence, in this case, yeah, frame 283, but I go back to 0, I can see the guy again. And again, here, this is important that where we start is always at the first frame, and this is where we need to identify which items to actually mask in this case. So my subject is person number 4, which was, he's about to cross the railroad track. So I basically turn off everything else besides person 4, because he's the only one I want to actually mask in this case. And now you can see that he's actually the one to be masked because you can turn him on and off. What's highlighted is bounding box will be the one which is actually masked in the end. Now if you scroll down to the run sequence, you push the run sequence button, and the whole process will start. This will take a few minutes, and maybe not a few minutes, maybe 30 seconds for a run sequence, depending upon your length of your video. And when it's done, it will basically report the video back, and you can see the first results as they happen. And if you play the video, you can see here's the guy as he's crossing the tracks, and you can see that the masking worked quite well. It tracked him all the way through, and the mask is completely surrounding him, and quite crisp. Sometimes it misses, of course. If you like, you can download the video by pushing on the 3 dots and get to the download link. This will give you your video back. So now at this point, we can say as a first try, let's go with the inpaint and see what happens. This will take quite a bit of time, so it could take 5 to 10 minutes depending upon the speed of your machine and the size of the video. So be prepared to wait and don't get too frustrated. However, I sped up, and here's the results right now. You can see right away that here we can see the first results. The person is walking across the track, and you can see slight ghost image, or basically parts of it which are not completely masked off. This is because of the sort of very tight mask which was used around the subject. So now the next part would be, can we make some improvements there? Now, if I go back to the process, start again, I have my person 4 selected, I have the entire sequence, and what I want to do is add some dilation in this case. I'll say I want to mask width, or mask half width of 10, which is basically 10 pixels. The full mask will be 21 pixels in width as it's actually applied. When I run the sequence, I can see that the mask size is much larger, and basically it's taking up much more room. This will make a cleaner transition around the person, and hopefully, yeah, clean up some of these ghosting effects. As you can see, it's tracked all the way through a sequence again. Now if we run inpaint, let's see what happens next. The inpaint button runs. And what I wanted to show you in the meantime is a few things which are useful for debugging. As you can see, as the process is running, it's giving some report back into the basically frame window, which is just some dots showing the activity, so you know that it's still alive. And if you open an NV-top session, for instance, like I have in the second window or second terminal here, you can see the actual action of the GPU. I have 2 GPUs on this machine, but only one of them is being utilized for this model, and it's basically loaded 100% or almost 100%, consuming about half the memory of the card, 4.2 gigabytes. And it seems to be running okay. Another thing to check, you could see what the processor speed or processor consumption is with HTOP, and what you can see here is that on this machine there is basically 4 physical cores, 8 virtual cores, and all of them are being used 100%, which means that the model is quite busy at this point. It's doing the heavy loading. If we look at a slightly later point in time, which I'll show, the model switches into a different course where it's doing interpolation. And this is a light, small deficiency in the in-paint model, is that it basically gets into a gill lock circumstance here, where it's utilizing multiple threads but only a single processor. And this is somewhat could be improved in this case, but it's what we're living with. Now back into the final results when it came out. Now you can see that when the in-painting is actually finished, there is quite a bit of results reported out what it did do. And you can see also the processor load has dropped off to almost zero. So now this will also be shown in the screen. Of course, our in-paint video is reported and given, and you can see what the results are in this case. There's quite a bit of improvement. There's still some blending effects, but this could be improved with basically some tuning and multiple edits if you like. Thank you very much for watching. I hope you enjoyed this, and I hope it was instructional.